Imagine a butterfly flapping its wings in Brazil, and a few weeks after, triggering a tornado to happen in Texas. Impossible, isn't it? Or is it?
To answer that question, we need first to understand the concept of the butterfly effect.
So what really is the butterfly effect? The butterfly effect, pioneered by MIT meteorology professor Edward Lorenz, is about
How tiny changes in big chaotic systems can have complex results.
Let us demonstrate this phenomenon through a simulation of a well-known chaotic system, the double pendulum. At first glance, we might assume that this pendulum's motion is predictable, sliding to the left, to the right, and back to the left side again. But we already know that a double pendulum is a chaotic system, and in chaotic systems, even a slightest change in the initial condition can create huge unpredictable outcome. When I created 3 setups of the same system, and slightly varied the initial position of the pendulum's bob, that is what I saw, the butterfly effect in action. In spite of the very little difference in the bob's initial position, we see each pendulum taking different paths of motion. Similarly, Lorenz realized the same thing about the Earth's atmosphere. In a day of year 1961, Lorenz was working on a problem of weather prediction. With his Royal MacBee computer, he ran a program that could calculate weather patterns. In his first simulation, he inputted an initial value of 6 decimal places. On the second time, however, he mistakenly inputted the same value but now with only 3 decimal places. Then, he saw something pretty unexpected. From nearly the same starting point, the pattern grew farther and farther apart, resulting to 2 entirely different weather scenarios. Wait, what? That small difference at the start creating that big change? That's crazy.
Yeah, things do get that crazy.
Now that we know that the atmosphere is a chaotic system, can a butterfly cause a tornado? Well, the answer is no. That is because, in Lorenz's own words, if the flap of a butterfly's wings can be instrumental in generating a tornado, it can equally be instrumental in preventing it. You get it? Huh? The real big deal here is that the butterfly effect is groundbreaking at its time because it challenged Newton's idea of a clockwise universe. In Newton's deterministic universe, anything can be calculated with utter precision. But we know that's not true anymore. Thanks to Edward Lorenz, his Royal MacBee computer, and this metaphorical butterfly.